Good evening, class. This is Mr. Picard, your well-rounded math teacher, and a little shout out to all the dog owners out there. We are going to cover complex numbers today, section 5.4. We're going to spend a couple days on this. Complex number, basically what we're talking about when we're working with complex numbers to begin with here is the square root symbol. Okay. Another name that we have for the square root symbol here is this. It is also called a radical. You guys haven't heard it called radical too much, but we do a little bit more with the square root symbol rather than just taking the square root. So you'll hear me call it a radical sign or a square root symbol, either or, same thing. A couple things we can do with radicals or square roots is we can break them up. You look here, if you have the square root of a times b, you can pull that apart and say that's the square root of a times the square root of b. Now, why would we ever want to do that? Well, you guys know what the square root of 4 is? Of course you do. Square root of 4 is equal to 2, because 2 times 2 equals 4. Another way to look at this, it's the square root of 2 times 2. In other words, what times itself will give you 4? Well, 2 will. If you have 2 of the same thing underneath the square root symbol, you can pull it out, and that is the root, 2. Square root of 4 is 2 because there's 2 numbers. You'd multiply those 2 numbers in order to get 4. In other words, what I'm trying to say is if there's 2 numbers that are the same underneath the square root, you can pull them out outside of the radical or outside of the square root. And that becomes your answer on the outside. So anyway, let's say we have the square root of 12. Okay, I know that the square root of 12 is 4 times 3. And I know the square root of 4 is a perfect square. So I would break this up using, this is like my A, this is like my B. This is the square root of 4 times the square root of 3. I can simplify the square root of 4. I know that is equal to 2. But I can't simplify the square root of 3. So I'm going to leave this as 2 square roots of 3 right here. I'm going to show you a couple different ways we can do this. But this is one of the reasons you might want to pull something apart. Also, you can go the other way. Let's say I add the square root of 2 times the square root of 8. I can't simplify the square root of 2. It's not a perfect square. Neither is 8. But if I say, well, the square root of 2 times the square root of 8, that's the same thing as the square root of 2 times 8 like this underneath one square root symbol, or the square root of 16. I know what the square root of 16 is. The square root of 16 is 4. Okay? So we're going to be simplifying radicals here. A lot of different rules. Hopefully you guys will get familiar with it with time when we work with them a little bit. As far as fractions go, a couple things about radicals or square root symbols. Simplified square root expressions do not have radicals in the denominator. Okay, we'll talk about that in a minute. And any number remaining under the square root has no perfect square factors other than 1. No radicals in the denominator. So in other words, I couldn't have an answer of like 1 over the square root of 2. You can't have a square root symbol or radical in the denominator. So we're going to try and talk about that and fix that. So this one, square root of a over b. First of all, you can't have a fraction underneath your radical symbol or your square root symbol. So they take care of that by splitting it up like this. So let's say I have the square root of 3/4. Well, I can't leave a fraction underneath my square root symbol, so I'm going to break it up. I can say that's the square root of 3 over the square root of 4. And from that, I can't simplify the square root of 3. 3 isn't a perfect square, but 4 is. The square root of 4 is equal to 2. And there's my answer. That's one thing you can do with square root symbols. Another thing is this. Let's say we had, how about the square root of 5/3. Okay. This is, I can't have a fraction underneath my square root symbol. So the first thing I got to do is break this up. This is the square root of 5 over the square root of 3. Well, I can't have the square root of 3 in the denominator. So what you do is this. You usually multiply by that same number 3, but I'm going to say this is the square root of 3 over the square root of 3. When I multiply by this, the top isn't a big deal. Square root of 5 and the square root of 3 is just the square root of 15. But on the bottom, when I multiply the square root of 3 times the square root of 3 here, I get the square root of 9. And I know the square root of 9 is equal to 3. So I get the square root of 15 all over 3. Once again, no square root symbol in the denominator. Where here, we do, and we got to get rid of it. And usually, we'll practice this more, but if you multiply it by itself, you get the square root of 3 times the square root of 3 is the square root of 9, and you can simplify that. Okay, so just a little bit with complex numbers to begin with. Something that will really help us succeed through these problems is knowing a perfect square. Yes, this is true. It's kind of a rough looking chart, but it's good to know all your perfect squares. 16 is 4 times 4, 81, 9 times 9, all the way down to 256, 16 times 16. So if I had a problem like the square root of 256, I know that's equal to 16. You could probably do these up to 20. Well, I'm going to show you a technique where we really don't worry about perfect squares so much as prime factorization. And what I mean by that is this. We're going to break these square roots or radicals down a little bit. So if I something as simple as the square root of 8, what they're saying, the way the book simplifies these is you got to recognize perfect squares. Well, is there any factors of 8 that are perfect squares? Yeah, that would be 4. This is the square root of 4 times the square root of 2. I know the square root of 4 is equal to 2, so this is basically 2 square roots of 2. Whereas the way I would do it, I think it's a little bit easier for students to do this, is you know the square root of 4 is equal to the square root of 2 times 2. If you have 2 of the same factor, you can pull it out of the radical or out of the square root and say it's equal to 2 like this. So the square root of 4 is, we know it's equal to 2, but why? Because there's 2 factors of 2. If you have 2 factors the same, you can pull them out of the square root. So what I would do with the square root of 8 is this. I know 8 is, using your little factor tree, find all the numbers, the prime numbers you would multiply to get 8. 2 times 4, 2 is prime. And then 4 is 2 times 2. They're prime. So this is actually the square root of 2 times 2 times 2. So simplifying this, you need 2 factors of the same thing in order to pull it out of your square root. There's 2 2's, so I'm going to pull them out of the square root and say that's 2. I can't take this one out, so it stays in the square root times the square root of 2. Or you would just simply write 2 square roots of 2. Okay, that's the prime factorization method. And that's what I'm going to be showing you mostly. But if you like this one where you just find perfect squares, you can do that method also. So simplifying square roots. 50. Okay, what I would do with this is I'd take 50 off to the side and say, you know what? That is 5 times 10. 5 is prime. 10 is 2 times 5. 5 and 2 are prime. So this is actually the square root of, what do we got? 2 times 5 times 5. There's 2 prime numbers. They're the same, 5. So I have 2 factors of 5, so I can pull that out, and it becomes just a 5 on the outside of my square root symbol. Can't pull this out. That stays the square root of 2. So 5 square roots of 2. Now when they say simplifying, this is your exact answer. You also could come up with an approximate. Approximate answer. And that would be just to plug this into your graphing calculator, you know, or any calculator for that matter. Okay, so I'm going to pull up the graphing calculator here. We're going to go to calculate. We're going to hit square root of 50. And hit enter. and you get 7.07. Basically, this decimal continues on forever. So this is an exact answer because the decimal doesn't quit. It's a non-terminating, non-repeating decimal. So the square root of 50, you could say, is 7.07. But that's not your exact answer. That's an approximate answer. Most of the time, we want an exact answer where you just simplify it down as best you can. So square root of 45, I would just do this. 45 is, oh, I don't know, 3 times 15. 3 is prime. And that's 3 times 5. 3 and 5 are both prime. So this is equal to the square root of 3 times 3 times 5. There it is. 2 3. So I can pull that out of the square root as 1 3. I can't take the 5 out. So it's 3 square roots of 5. And that is my exact simplified answer right there. Okay, next. Square root of 128 and the square root of x squared. Okay, 128. I don't know what the perfect squares, if there are any perfect squares in there. So I'm just going to start breaking this down. 128 is 2 times 64. 64 is a perfect square, so I could just stop there, but I'm just going to keep going. 32. This is 4 times 8. These are prime. 4 is actually 2 times 2. And then 8 I know is 2 cubed, so I'm just going to put 3 2's up here. Oh, not a 3. Prime, prime, prime. So how many 2's do I have altogether? 1, 2, 3, 4, 5, 6, 7. So I'm going to say this. The square root of 2 squared times 2 squared times 2 squared times 2. There's 7 of them, right? So here's 2 2's, 4 2's, 6 2's. There's 7 of them all together. It's just a shorter way to write it, I guess. So I can pull these 2 2's and put a 2 on the outside. Pull out these 2 2's, put another 2 on the outside. Pull out these 2 2's and put another 2 on the outside. I have to leave this one in because I don't have enough of them to pull it out. Square root of 2. Now we're just multiplying all these 2's. 2 times 2 times 2 is 8. Square roots of 2 is my final answer. Now we could have done that right here. Square root of 128 is the square root of 2 times 64, which is equal to the square root of 2 times the square root of 64. And the square root of 64 is 8. So this becomes 8, and then the square root of 2 you put on the end. Square root of 2. Either or. With variables, for D here, it's x squared. So what do we have there? We have an x times an x. There's 2 of them. So I can pull it out and say this is equal to just simply x. Another way to look at it is this. The square root symbol and squaring something are inverse operations. So they basically cancel each other out. And all you're left with, once again, is an x. Okay, we got time for a couple more here. So working with this problem right here. You got 25 x squared and y to the 4th. What do you do with all of them? Well, you could do prime factorization for the whole thing if you wanted to. You could say 25 is 5 times 5. So I'm going to pull those 2 out. X squared, you know, is just going to become an x on the outside, but just looking at it like this, it's x times x. And then y to the 4th, that's 4 y's. For each 2 y's, you can pull one out, pull them out, and have a y on the outside of your square root symbol. So instead of having 4 y's here, I'm going to say y squared times y squared. So I can pull a 5 out. I can pull an x out because I have 2 x's there. Here's 2 y's. I'm going to pull that out. It becomes a y on the outside of the square root symbol. And another y. So cleaning up my answer here, this is 5 x times y is just x y squared. And there is my answer. 5x y squared. Beautiful. What do we got here? Okay. First of all, you can't have a fraction underneath the square root symbol, so I would say this is the square root of x squared all over the square root of x. this is going to give me, well, I know the square root of x squared is this. Square root symbol and squaring something are inverse operations. This is just x all over the square root of x. But I can't have a radical or square root symbol in my denominator. So I have to do this. Here I have 1x. How many x's do I need in order to pull that out of the square root symbol and get rid of it? 2 of them. So I'm going to multiply this denominator by the square root of x. But whatever I multiply the denominator by, I have to multiply the numerator by, because the square root of x times the square root of x, well, that's, I'm sorry, the square root of x over the square root of x, this is equal to just 1. So I'm not changing the value of my fraction. I'm just kind of rewriting it. So multiplying x times the square root of x, this x is on the outside of the square root symbol, so I don't put it underneath the square root symbol. So it just stays x, square roots of x. Here, I have the square root of x and the square root of x. That becomes the square root of x times x. Well, now I have 2 of them. I can pull it out. This becomes x, square roots of x all over x. And for that matter, what is x divided by x? Well, anything divided by itself is equal to 1, so these cancel out. I'm left with the square root of x over 1, or just the square root of x. And we are done for today. We'll do some more of these tomorrow in class, and we're probably going to do a couple CFAs. I'll have you guys work on a few of these in Schoology and then put them back into Schoology in my Dropbox. So we'll see you tomorrow. We'll do that. And shout out going out to all the people that like to deer hunt. Oh, we already did that one. Shout out to all the people that hate deer hunters.